up until this point, well, we've said that you can have two horizontal asymptotes for the graph of a particular function, but we've only seen one. We're looking at rational functions. We only expected one of them. So example 10 is going to lead us into cases where we can have more than one, where we can have two of them. So you can see on the surface, these are some pretty simple questions. There's actually no calculus involved here, right? So evaluate the square root of 3 squared. So one way to think of this is that the square root and the square cancel each other out, and I'm just supposed to get 3 back. Okay. Another way to think of this is I take 3 and I square it first, and I have the square root of 9, and the square root of 9 is 3. Now, just keep this in mind. I am not getting plus or minus here because this symbol is the principal square root, which implies the positive one. If we wanted the negative one, you have to throw the negative sign on the outside of this. Okay, so likewise, I might expect over here on number 2, the square and the square root to cancel out, and that I would get negative 3, right? What's happening here? Come on. Negative 3. Except you don't, because whenever I square the negative 3, I get 9 again, and then the square root of 9 is 3. And we often think of squares and square roots as being direct inverses where they cancel each other out. And remember, the definition of inverse goes like this: f composed with f inverse of x. When you do that composition, you put an inverse inside of the original function, you're just supposed to get the original input back. You're supposed to get x back. But that didn't happen right here. I didn't get the original input back. I didn't get just negative 3, I got positive 3. Again, it's because there's a subtle thing that's happening here between square roots and squares. So on number 3, when we ask what is the square root of x squared, is it as simple as just x? And the answer is it's just not. So let's take a look at the next couple of slides here, some animations. I have the graphs of each of these. So I've got f of x being x squared, g of x being the square root of x, and then we're going to do a composition where x squared goes into the square root of x. It goes into the g of x function in order to make this h of x function, which is basically what we're trying to evaluate here on number 3, seeing what happens. So what I'm going to do is just take some points that are on the graph of f of x. Like, for example, I'm going to take the point negative 3, 9. I input negative 3, 9 comes out. Now I'm going to take 9 and put it into the g of x function. The square root of 9 is 3, so it makes the point 9, 3 on the square root function. Okay, but the composition is going to take the original input of 3 and pair it up with the output here of 3. Negative 3 is going to go to 3 and make that first point on the h of x graph, the square root of x squared. Okay, let's do another point. So for example, this time if I stick in negative 2 and square it, I get 4, of course. Now I'm going to take that 4 and put it into the g of x function, the square root of 4. Principal root, square root of 4, is a 2. And then I'm going to pair the original input, negative 2, up, and it's going to spit up positive 2. So you get the point, negative 2, 2. Maybe you see where this is going. Let's try another one here. Okay, so if I stick in 1, square it, I get 1. I put 1 into the square root function. I put 1 into the square root function, and you can see that I get 1. So the point, negative 1, did I say 1 over here? I meant negative 1. Anyway, so negative 1 is going to get paired up with positive 1. The origin, if I square the origin, 0, I get 0. Square root of 0 is 0. And so then the original input of 0 gets paired up with 0, and then I have 0, 0 on the h of x graph. All right, okay. And then let's do the positive side over here. So on the positive side, if I stick in 1 into my f of x function, squared, I get positive 1. I take that positive 1, I put it into the square root function, I get positive 1 again. And so the original input of 1 gets paired up with the output of 1, and I get 1, 1. Ooh, where's this graphing going over here on h of x, I wonder? Okay, let's do a couple more here. If I plug in the number 2 on the f of x graph, 2 squared is 4, put the 4 into the square root function, and I get 2 over here. So I'm going to pair up 4 with 2. Do you see what's happening here? And then again, I'll just do one more. I plug in 3. 3 squared is 9. Take square root of 9 to get 3, which pairs up 3 with 3, positive 3, positive 3. And you can see that what a graph that I have is the absolute value of x. And this is very important, that whenever I take the square root of x squared, you don't get x, you get the absolute value of x. And this is going to come up in the next couple of exercises here. So definitely write something down here. The square root of x squared is equal to the absolute value of x, and then you can write the absolute value of x as a piecewise function. Well, sure, the absolute value of x is supposed to be the distance away from 0, but another way to think of it is if your number is positive, the absolute value doesn't do anything, and you output the number x for everything greater than or equal to 0. But if your number is negative, to get rid of that negative sign, you negate it. So that x, absolute value of x, becomes negative x for everything less than 0. And again, if I look back at that graph over here, that's exactly what's happening. This is y equals negative x on the left side, and this is y equals positive x on the right-hand side.